Welcome back to another video in the College Algebra series. Today we're talking about inverses and how to find or how to determine if a function has an inverse, and as well as how to determine what if it does have a function, or if a function does have an inverse, then what is the inverse of that function. Okay, how you do this graphically, it's really pretty easy. When we're trying to determine if a function if y is a function of x, right, we use the vertical line test. Well, to determine whether if a function has an inverse, you use what's called the horizontal line test. Okay, so I'm going to take a horizontal line and I'll do it in blue. Okay, and as long as this horizontal line, now instead of going left and right, this horizontal line is going up and down. So as long as this horizontal line only crosses the graph once, right, your function does have inverse. So in this case, the graph of some function, probably some cubic function, this would have an inverse, and so you would say yes, it does, right? So so if you're ever given an equation and it says determine if this function has an inverse, instead of doing some algebraic way, right, just put in the graphing calculator and kind of take your pencil and just kind of say, okay, does my pencil cross horizontally? Lay your pencil across the graph and just kind of slide it up and down. Does my pencil cross the graph more than once? If it doesn't, then it passes the horizontal line test. Thus, it has an inverse. So you'd say this would be yes. It has an inverse, right? Now, this one, the graph of y equals x squared minus something, right? So if you look at it, right? So if you look at this, this does not have an inverse because my blue line has crossed this graph more than once. So your answer to this would be no inverse, right? Now find the graph of inverse of a function's inverse. All right, so this is kind of it's a little weird how you do this. Basically, you kind of have to remember back to geometry and the idea of reflections, right? So you're going to basically create a mirror image of something across a line of reflection. Okay, now what's this line of reflection for an inverse, right? This line of reflection for an inverse is the line y equals x squared. So I'll just kind of draw a line. This red line is y equals x squared. If you think about it, y equals x squared, your y-intercept is 0, so it goes to the origin, and basically your slope, right? So if you look at it, so remember y equals x, your slope is 1, so it's going to go up 1 over 1. So it's just kind of a nice slanted line, like 45 degrees. So basically, this line of reflection, this is your line of reflection. So everything below the line is now going to go above the line, and everything above the line is going to go below. So you can kind of get an idea what it's going to look like. So you're going to go through the origin, so because it's on the line, right? Now it's kind of going below, and it crosses here, right? So I'm going to kind of just lightly kind of mirror this black line just above the red line, right? So I'm going to kind of do something like this. Now, if I look above, this black line goes above the red line. So now I'm going to go below, right? So kind of keeping it all the same, right? And then now looking at this, the negative x side, right? This black line crosses my line of reflection here. So that's another point that's useful. And it comes down, right? And it comes back together, right? And it goes out like that. So the graph of your blue line is actually the inverse the graph of your inverse. And that's how you do it. You just kind of just draw a diagonal line of y equals x. You graph it, you roughly graph it, and then you just reflect if the graphs, you kind of put your kind of critical points where your the graph that you're reflecting crosses your red line, and then your line of reflection, and then you just go in the opposite direction. Okay. Now, how do you do it algebraically? It's a little bit easier than this kind of just weird kind of reflecting thing. So here's the process that I teach my students, right? So you're given f of x equals 2x plus 6, right? So change f of x to y, 2x plus 6. Okay, now you want to interchange x and y. So you have x equals 2y plus 6. Now you have this equation, and now you want to solve this new equation for y. So I'm going to subtract 6. So I'll get x minus 6 equals 2y. I'll divide it by 2. So y equals x minus 6 over 2. Now they might write it as this. They might write f negative 1 of x equals x minus 6 over 2. That indicates that the inverse of f of x, which would what you started with, is equal to x minus 6 over 2. Okay. Now, how do you do this for square root functions? Okay. So nothing new. So y equals the square root of 4x minus 6. Okay. Now, how do you get rid of square roots? Well, no, hold on. Take that back. Okay. Next step, interchange x and y. So x equals the square root of 4y minus 6. Now, how do you get rid of the square root? You square both sides. Okay, what you do to one, you do to the other. So you have x squared equals 4y minus 6. Now, solve for y. Add 6. So I left with x squared plus 6 equals 4y. I'll write that up here. So x squared plus 6 equals 4y. Divide by 4. So you get x squared plus 6 over 4 equals y. And that's your answer, which equals f negative 1 of x. Okay. Now, this is where it gets a little weird. What if your function that you're trying to find is a absolute value, right? Well, if you remember, absolute value of a graph, right? So kind of looking at your graphs. Okay, so absolute value, x minus 2, right? X minus 2, so that means negative absolute value of x minus 2 minus 1. So this graph has been shifted down 1 and to the right 2, and because it's negative, that means the arms are going down instead of up. So I've shifted to the right 2, down 1, okay, and it's a negative. The graph of the absolute value is a negative v, right? It's a v. Now, looking at this, if you go back to what I said at the beginning, this would fail the horizontal line test, okay? But here's where they like to, this is what they add in, okay, where x is greater than 2. So what does that mean? That means they are ignoring that line, okay? So they're ignoring that line. So you have this line of this line right here, okay? So how do you do this? How do you find f negative x? So now, looking at this, the horizontal line test would pass, right? It would never cross more than once. So here's what you do. So you have f of x equals the negative, and because now you've eliminated one side, you can drop the absolute value bars. So you have negative x minus 2 minus 1. Now you distribute the negative. So you have negative x plus 2 minus 1. So you have f of x equals negative x plus 1. Okay? That's the equation of this line, this side of the line. Okay? And now you follow the same rules as above. Change f of x to y. Interchange x and y. Okay? Solve for y. Subtract 1. X minus 1 equals negative y. Divide by negative 1. You have negative x plus 1 equals y. Okay? And there is your equation. It looks very, very similar to 1 of x. Okay? To what you started with. Right? It's kind of weird, but that's what you do. That's how you do absolute values. If you have any questions, I'd love to help. Please leave your question in the comment section below, or you can email me in the description. Yeah, thanks.